the type. So okay, given a type, looking at C# then, C# type class. Okay, we can get a decent amount of data off the type. Okay. The assembly, once the type is declared, attributes, gets the base type, contains generic parameters, no custom attributes. Be lovely to know what custom attributes are for, but okay. It's class, is constructed, generic type, is contextful, is enum. Okay, is interface, is public, is sealed, is security critical, is special name. What does a type handle do? You can get a runtime type handle. No, not the not support exception. I wanted the other one there. I wanted runtime type handle. Represents a type using an internal metadata token. Okay. You can obtain a runtime type handle, or type or an object, and then turn it back into a type. Neat. But okay. Lovely, but no. All right, what we're trying to do here is we're trying to figure out how to pass just the type and have this thing do the instantiation itself based on what that type is. All right, let's see. Let's look here again. Let's look at a specific instance of a game screen, which is going to be puzzle canvas. So, right, you want to change your scene to another scene. And in order to be a game screen, you've overridden file name, and that's basically it. You just need to say what file hosts your scene so that you are instantiable using the game screen instantiate logic. But then what I want to do, right, we see instantiate that as a game screen. Okay. I'd really like to not need to know what that name is. Okay, the file name is actually, and should be, static. The file name is data about the class, not data about an instance of the class. Okay. So let me see. Can I public virtual static string foo? Modifiers are not ordered. Okay, we can have a static virtual string, which means that can be file name. Now, right. The modifier virtual is not non-constant fields should not be visible. Hang on. What does it mean the modifier virtual is not valid for this item? Static is not printed a local function. No, not public, abstract. Access modifiers not allowed in the local function. Local functions are always private. Read only is not allowed on methods in a. Okay. C#. I want to override a static value in subclasses. It requires an explicit action. Right. Can a static method be overridden? Oh no, okay. Okay. Public static virtual string get file name. A static member cannot be marked as virtual. Static methods cannot be overridden. They can just be, okay, hidden using the new keyword. Since that's are part of the type and aren't subject to vtable lookups. Okay. Okay, so basically, I need to ensure that, okay, to be a game screen, I need to ensure that you have a file name that I can look up. So if I do, I could use an interface to enforce that that's there. Because the key thing I want to make sure of is that whatever we're changing to needs to have a file name. So, okay, if we get rid of file name here, okay, control, and right, at that point we can't do file name because this thing doesn't have that. Okay. So, okay. Instead, we're going to say, yeah, protected game screen instantiate from string file name. And we're also going to say public abstract game screen instantiate. So the children have to implement this. And they have a helper that they can use to implement it, which will do all the caching and things for them. So what we just need now is to say, yeah, if you are doing that, that gets you your signal, that gets you that. And now what we need to do is we need to also construct, I think, new file, igamescreen.cs, namespace, brain better, public interface, igamescreen. All right, and now this has to require to be an igamescreen. I think we need to say, yeah, you must have, can I, static string file name get. Uh-huh. Oh. Suggesting we put required on it, but required isn't valid. Sure. Thanks. Great. Okay, so now to be an iGame screen, you must have file name. So now if we come back on over here to Puzzle Canvas, doesn't implement, yep. So it's a game screen. It's also an iGame screen. So now it needs to have static override string file name. A static member cannot be marked as override. Oh, a static on the interface is literally static on the interface. I can't require that a class has a static field. That is really annoying. Because I want to be able to check that if you get a hold of that class, that you will have that static field. Though, actually, okay. Let's kill iGame screen. Or at least let's null it out. It's a do nothing. Let's remove it from here. So now we have this, and now we have the problem that puzzle canvas does not implement instantiate. So override instantiate, and all that's going to do is it's going to say instead of overriding game screen instantiate, and overrides puzzle canvas instantiate, which is still a valid override because of C# typing. Instantiate file name. Right. And we say instantiate, and we explicitly cast that to a puzzle canvas because we know it's us, and we instantiate the file name like that. Okay, so that's the instantiate implementation there. So if that works, now what? Now we have to come back here. We still want to be able to say we're changing the scene to something. So we come back over to, well, there's game screen. Just save that. We come back over to game here, and we're going to see we have the type now. But instantiate needs an instance. Instantiate's supposed to be static. Right, because instantiating one of these, you shouldn't need to get one of them. In fact, you can't really get one of them. Oh, that's a mess. Yeah, because we need the thing to be instantiated from its scene. Okay. Right, because when we instantiate it, we're in fact going to, we get the packed scene, then we instantiate the packed scene. And we need to know what the file name is in order to do that. Okay. Actually, though this can be static, can't, no, yeah. That can just be static. So instantiate on, oh no, that won't work because that is now static to all instances of game scene, which means anytime we load one of them, it's going to load that type of scene. Nope, that's going to do crosstalk. That's bad. Okay. What we need to do is we need to be able to basically make sure that all of these things, that every game screen that we build, again, I guess you're not a global class, are you? Okay. We build you as a game screen, then, right. Basically, I want a type that can be moved between. So the idea here is I'm trying to build a type so that these nodes, you can say, hey, I want you to change, but only to another node that implements this contract, which is the game screen contract. So, okay. If you are a game screen, you can invoke change scene to, which will emit the signal. If you have a scene, right, this does that. This actually is not that helpful because instantiate, right, the resource loader will redo that load. Okay. Let's go ahead and unback that. Yeah. So this is just, we take the resource loader, we tell it to load packed scene file name, and then we tell it to instantiate the game screen. instantiate as a game screen. That's how we instantiate one of these things. But there's no yeah, and that's there as a helper that those guys can use. But we still need to make sure that individual game screens can have the ability for us to do certain things. So C# enforce presence of static method on subtype. Is there a way to force a C# class to implement certain static functions? What do static methods have that ordinary? You don't need an instance. Yep. Use the interface without knowing whether you're working on an instance or a type. Yep. No. Use reflection at runtime, cross fingers and hopes. 2. Use a singleton. Okay. Okay. Use reflection at runtime. Okay. So, I mean, all right, this guy's written some generic operators code that works kind of that way. Okay. I mean, I can work with this, I think. Let me take a look here. Wait, I do want to see here, yeah. Mark Gravel. Okay, yeah, that is the person who wrote it. Okay. So yeah, if we take a quick look at this here. All right, looking at the operations there. Yep. What I'd like to see here. I can for any type. Yes. Operator class provides an alternative operator.add AB. The add method is actually a generic method. Uses type to work out the type of T automatically. Yes. Okay. Nullable. Right. The two following. Okay. The operator class. Okay. I'd like to see how operator is implemented if possible, because I don't see the scenarios here. It's just miscutil. Okay. So that's how they're used. Aha, part of miscutil. A push model for link. Okay. Okay, so yeah, this is just part of the of that. Source distribution, clean source. Oh, no, I don't want a clean source tree ready to build. Ugh. Okay. Let's take a quick look at what we can do here. So I think we need to assert. This is going to be a little bit like what we were doing with the task thing. Okay. So if you are going to be a game screen, okay. Yep. So to be a game screen, there's a couple of things that we need to be able to do. Yeah. So you need a static 0 arg instantiate method that returns an instance. Is that all we really need? Because if we've got that, if I can just assert that if as a game screen you have a static 0 arg instantiate method that returns an instance, and that it must also be a child of this. Yeah. Okay. So what we're gonna say here, right? If target scene is subclass of type of game screen. Actually, yeah. Let's go ahead with type target. Hang on. Target type. Okay, so we're gonna try to change scene to a given type. So the first thing we need to do here is I'm gonna say yeah. If not is target type is subclass of game screen. Throw new. Throw new argument exception. Okay. So then next thing we've got is I want to ask the question target type dot. And now what I want to find out here is do I have not get its fields? I'm looking for with reflection. I want to go looking for a static method of the name I need. So we've got this thing. Now it has element type. Declaring things, the default binder, blah, 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 blah. Okay, nope, is collectible, is generic, is import, is interface, is nested. What I'm looking for right now, oh no, okay, methods, here we go. No, were those the methods or are those, no, those are just the properties. Okay, right, methods. What I want to do is find, find interfaces, find members, get constructors, get default members. Do we have anything in the get static? P R T. No. Can I find anything on here that has static? No. In the type class. All right. C#. So given, okay. Type.get methods. Okay. And binding flags. Okay. Search the methods of the current type. What are binding flags? How the search is conducted. Nor case declare. Aha. Static are to be included in the search. Great. Inherited members are not considered. Okay. So there we go. Searches for the public method with the specified name. Okay. So target type.get method instantiate is going to hopefully return a method info. So now instantiate, so now I have this method dot invoke. Can I do that? No overload for method invoke takes 0 objects. Using the specified parameters. So okay, let's take a quick look at what that thing returns. So if we go back over here, we get an array of method infos. Let's look at what a method info can do for us here. You can determine stuff. You can determine whether a method is, yep. You can execute a method on a class instance by calling the invoke method. Is stat, yep. Okay. If it's static, right, it cannot implicitly reference instance data in a class. Invoke on an object, invoke on an object is defined. Get type, get parameters. Okay. I mean, okay. C# invoke static method from type. Okay. So I know the type, value of the type variable and the name. Yes, there we are. Method info dot invoke. Oh, right. So we can call it with on null, a null object. Okay. Okay. Method info class and the get method. Yep. Okay. So yeah, we don't need to give it anything. Yeah, but it's possibly null. All right. So uh, if instantiate is all right, this thing is a what is it? Method info. Using system.reflection. Okay. So if instantiate is a method info, so hang on. Let's go ahead and yeah, no, we'll use instantiate for that name instead. So var equals if method is method info instantiate, we're going to say instantiate.invoke with null null. And what we're going to get back from that is we're going to end up with a game screen. Right, game screen equals instantiate.invoke null null. Right. As game screen. We're converting a null literal or a possible null value. Right. So this is a game screen. Okay. So now we can say screen equals instantiate invoke that as game screen. Then if screen is actually no here F2. Yeah, maybe screen. If maybe screen is game screen. At that point, in game screen, right, we do not actually. Oh, no, do we emit a signal? Oh, this is in the game screen. Well, crap. This is, in fact, the wrong place. We're going to grab all of this, Control X that. This one actually just emits the signal. It's in game where we're going to do that, where this all has to happen. When we change the scene to this, we get the target. So there's our type, type.get method instantiate. No, right. So what I want to say here, yeah, type question maybe type equals type.get type target. Then if maybe type is type, we can now go ahead and get our method. Great. And then this is right. Okay. Because we need to do a lot of type safe refinement in here. So if the maybe type is the type, then we've now got our hands on that. We can ask it for the method instantiate. The thing I don't love here is that, well, actually, we're going to do it like this instead. Type maybe type equals Yeah, let's see. Yeah, type maybe type equals type.getType target question question